Hello and welcome to the InteliMap PRO Advanced Guide. In this guide, you will learn about all the different settings and how to use them, how to use prefabs as tiles, and how to use the API for runtime generation. As with the Quick Start Guide, you will need InteliMap PRO in order to follow along, so you can find it on the Unity Asset Store or by clicking the link in the description. As you can see here, I am opened up to the Dungeon Platformer example scene. Firstly, we will go over all the settings for the InteliMap Builder component. The first setting is epochs. This is the number of times the generator will learn from the build maps. Increasing this will increase the build time, but may improve the quality of generation. The next setting is the generator to build. If this is empty, building a generator will prompt you to save a new generator data scriptable object. If this already has a generator data object assigned to it, then building the generator will continue to train that generator, as well as reset all of its connectivity data. The last setting in the general section is the neighborhood radius. The neighborhood radius is the radius of tiles around each tile that should influence what that tile becomes. Typically, a value of 2 or 3 is optimal for this setting, but you may want to increase it for more complex tile maps. Very importantly, the InteliMap builder has a list of build maps. These are the areas of tile maps that the builder will learn from in order to build the generator data. An entry in this list has many properties: the map layers, which are the tile map layers, the commonality, which I will explain shortly, and whether to use manual bounds or automatic bounds. If you use automatic bounds, the entire tile map will be included. Now for commonality. This is demonstrated really well by the orthographic dungeon example scene. A build map's commonality corresponds to how heavily weighted that build map should be. A build map with a commonality of 2 will have twice as much an effect on the resulting generation as a build map with commonality 1. You can also set the commonality of a build map to be 0 if you don't want to generate maps that look similar, but you want to include that map so the builder has more information about which tiles are allowed to be connected. This is because the builder allows 2 tiles to be connected only if they appear connected in any build map. Thus, setting the commonality to 0 gives the builder this connection information without attempting to generate maps that look similar. Now we have the advanced settings for the builder, which are split into the generator settings and the training settings. The first setting in the generator tab is connectivity. Connectivity is whether to enforce connections only orthogonally with 4-way connectivity, to also enforce what tiles can be connected diagonally with 8-way connectivity, and also hexagonal connectivity, which would be used for hexagonal tile maps. Enforce border connectivity is which borders it should enforce connectivity for. If this is set to true for a border, then tiles will only be allowed to generate on that border if they appear on that border in any of the build maps. Interpret empty as tile dictates whether to include empty tiles in the generation or not. This is used in the floating platformer example scene. You can see here that there is completely empty area in the build maps, and then the generator specifically places those empty tiles. Next are the positional input settings. These dictate which positions to use as an input. Thus, if the use Y position as input is set to true, the generator may correlate certain Y positions within the area to generating certain tiles. Finally is the acknowledge bounds setting. This is which boundaries should be used as an input for the generator. Essentially, if a tile's close proximity to a border should affect what that tile should be. The last section on the builder is the training settings. First is the training threads. This is a new setting with InteliMap PRO that allows for vastly faster build times. This is essentially how many threads to use to concurrently train the generator. Increasing this number should result in faster build times, provided that your system has enough resources for each thread. As a general rule, for optimal performance, this should be equal to the number of cores your machine has. Finally, the starting and ending learning rates are essentially how fast to train the generator. The starting learning rate is how fast to train at the beginning of the build, while the ending learning rate is how fast to train near the end. Increasing these values may result in faster generation. However, be careful, as setting these too high may cause errors that can corrupt the generator and render it unusable. Now we will look at the settings for the InteliMap generator component. The first setting is the generator data to be used to generate tile maps. The generator component cannot function without this value being set to a generator data scriptable object. The next is the map to fill, which are the tile maps to use as layers for the generation. This is followed by the bounds to fill, which is the area to generate in whenever the generator is called to generate. Note that generation will only take into account tiles that are within these bounds. As such, it will not attempt to connect these tiles in a way that makes sense, because their areas do not overlap. Thus, if you want to ensure that two areas connect properly, make sure to generate with a sufficient overlap. Next is the Generate on Start setting. This is a simple setting for whether to generate upon the scene starting. Next is the Forceful setting. If this value is set to true and the generator is called to generate in an impossible area, instead of aborting, the generator will generate anyway, removing some of the previously placed tiles while attempting to preserve as much of the original tile map as possible. So this setting should be set to true if failing to generate is unacceptable, or false if removing previously placed tiles is unacceptable. Next is the Temperature setting. This is essentially how random you want the generation to be. Higher numbers may result in more random generation, while lower numbers may result in more consistent generation. You may want to increase this number if you feel like the generation is too bland, or decrease it if the generation is too chaotic. Next is the Random order. This is the portion of tiles to place completely randomly, instead of wherever the generator is most confident in. Thus, if this is set to 1, every single tile will be placed in a completely random order, while if it's set to 0, it'll be placed in the order that the generator is most confident in. You may want to increase this value to break up unwanted repeating patterns. The next settings are for a timeout. This will abort generation if the generator takes too long. By default, this is on and set to a timeout time of 20 seconds, but this can be changed or toggled on and off if you so choose. The final settings are related to animation. They will allow you to animate the generation instead of doing it all at once. This is set to off by default, but you can toggle it on and also adjust the speed of generation. Now I will explain how you can use prefabs as tiles. InteliMap uses Unity's built-in tile maps and stores tiles using the tile-base object. Thus, you can implement your own unique behavior by extending the tile-base scriptable object. A link to the Unity scripting API page for tile-base can be found in the description. Now, InteliMap PRO comes with a prefab tile scriptable object, which can be used to generate prefabs as tiles. To use the prefab tile scriptable object, navigate to your tile maps folder, right-click on your assets, create, InteliMap PRO, prefab tile. You can then set the sprite and prefab to whatever you would like. You can then add this tile to a tile palette just like you would with any other tile. Note that the prefab may not show up in the tile palette. Now, if you draw with this tile, InteliMap will be able to recognize it just like any other tile. And as you can see, now generating with this tile map causes those prefabs to be spawned. Lastly, I'd like to show you how to use the simple API for runtime generation. I'm currently in the planes example scene, and I'm going to open up the planes controller script. As you can see, on line 35, we call start generation async on an InteliMap generator object. The asynchronous generation methods are new in InteliMap in order to prevent lag spikes or loading times. Calling these functions makes the generator start generating within its bounds to fill. So to write your own runtime generation, you'll first want to modify the generator's bounds to fill, then call start generation. There is also a clear bounds function, which completely wipes the tile map within its bounds, as well as a start generation with seed function, which allows you to do seeded generation. That is all for this advanced guide. If you have not yet purchased InteliMap PRO and would like to check it out, you can find it on the Unity Asset Store or by clicking the link in the description. Thanks for watching.